Bismillahirrahmanirrahim. Dear students, grade 11, and we are going to start chapter number 12, last chapter, electrochemistry, and this is lecture number 66. So, in the electrochemistry, we will start oxidation and reduction according to reduced levels. So, first of all, I want to explain what's the electrochemistry. Electrochemistry, the branch of chemistry which deals with interconversion of electrical energy and chemical energy. Interconversion of electrical energy and chemical energy is called electrochemistry. So basically we start oxidation reduction reactions. So in both types of the cells there is a oxidation and reduction. There are two kinds of cells we will explain. One is called electrolytic cell and another is called a galvanic cell. That's why definition is that interconversion of electrical energy and chemical energy. So in the electrolytic cell, where the electrical energy derived change into chemical energy, means we have to continuously give energy to proceed the chemical reaction, oxidation and reduction, to drive the cell. So these types of cell are non-spontaneous redox reactions, and continuously amount of energy is going to be supplied. So these cells are called electrolytic cells. Another one is called galvanic cell or voltaic cell. In these kinds of cells, the redox reactions are spontaneous and the chemical energy changes into electrical energy we buy a cell from the market. So in these two kinds of the cells, the oxidation reduction process is involved. That's why we start oxidation and reduction. In lower classes, you've done three definitions of oxidation. Oxidation is a gain of oxygen, addition of oxygen. Iron changes into rust, oxidation. And removal of hydrogen and loss of electron. And increase in oxidation number is called oxidation. Mostly metals, they lose electron because they have less number of electron in the valence shell and they are more electropositive. That's why they can lose electrons very quickly to give positive charge. So there will be oxidation. And reduction, inverse of this, removal, loss of oxygen, addition of hydrogen and addition of electrons. And the oxidation number is going to be decrease. So here is oxidation reduction process. When we are going to a piece of zinc metal is dipped in aqueous solution of copper sulfate. So students, this is a container, and this container contains 1 molar solution of copper sulfate. This is the copper sulfate, and we are going to dip zinc plate. So when you are going to put a zinc plate in a copper sulfate solution, so it is in the observe that dark brown layer of copper begins to form at a zinc surface. At the same time, the solution loses the blue color. If we analyze this solution, we find that there will be a slowly and gradually oxidation reduction. Next case. So after the passage of time, you will see that zinc metal has a low charge 0, copper sulfate in aqueous solution blue color, this color is blue, and slowly gradually it will be dark brown, and there is a dissociation into ions and change it into zinc sulfate and copper solid. So this reaction is called a displacement reaction. Displacement reaction, and here there is a oxidation, loss of 2 electrons, oxidation number is going to be increased, and there is a reduction, and this will be a gain of 2 electrons, and the oxidation number is going to be decreased. So when I put the zinc rod, zinc plate in 1 molar solution of copper sulfate, which is a blue color, and slowly and gradually by the passage of time, you will find that blue color of the copper sulfate is going to be lost, and there will be formation of copper metal. So these chemical reactions are called displacement chemical reaction, and there will be oxidation and reduction. So there is a very important thing. Students, if I am going to inverse of this, if I make a 1 molar solution of zinc sulfate, I am going to make a 1 molar solution of zinc sulfate, and I put the copper rod here. So is this chemical reaction spontaneous? Is this chemical reaction taking place? Is there oxidation reduction? No. The copper will not displace zinc. Copper will not displace zinc. Copper will not reduce zinc. The reason because we will do electrochemical series. According to electrochemical series, there are reduction potentials given. There are active matters. Zinc is more active or reactive than copper. Zinc has a more negative reduction potential. Copper has a more positive reduction potential. If you look the table, electrochemical series table, all the reduction potentials are given. So on the top, you can see the most negative value. So the more negative value shows that it has ability to more oxidize. If you go down, this negative value decreases, and the middle you will find 0 for the hydrogen, which is the standard. Hydrogen will be the standard, and it has a 0. Then the positive starts. So according to electrochemical series, zinc has ability to reduce copper and displace from the solution itself oxidized to give a zinc sulfate and copper. So this is according to electrochemical series, but from this cell you will be unable to measure the electrode potential. We will unable to calculate the electrode potential. Dear students, loss of electron is called oxidation, increase in oxidation number, and the gain of electron is called reduction, decrease in oxidation number, if there is oxidation reduction, this is called a redox reaction. This where there is oxidation reduction, so I can write in this form: plus copper ions in aqueous solution to give a zinc positive 2 ions and copper 0. So this is the redox reaction. This is the redox reaction we have here. So if there is oxidation reduction both. So in the redox reaction, loss of electron and gain of electron taking place. Oxidation number or oxidation state. Oxidation number or oxidation state means apparent charge. Apparent charge on an atom in a compound is called a oxidation state or oxidation number. Apparent charge positive may be negative in the molecule hydrogen, oxygen, nitrogen, chlorine, iodine, bromine, 0. Metals, individual metals, iron, zinc, silver, mercury, gold, nickel, cadmium, 0. Sodium, magnesium, individual 0. The oxidation number or oxidation state is defined as, I told you that, apparent charge positive or negative which an element would have in a compound is called oxidation state or oxidation number. Dear students, I told you that alkali metals, which are group number 1 element, they have always positive 1. Alkaline earth metals, they have a positive 2. Group number 3 element, aluminum, has positive 3 in a compound. You should remember these. There are no change in these. Oxygen, mostly negative 2 in a compound. Mostly. In the case of peroxides, then there is a negative 1, or in the superoxides, there is negative half. But in the normal oxides, and mostly normal oxides are going to be used, they have negative 2. Hydrogen is mostly positive 1. But in the case of metallic hydrides, then hydrogen is a negative 1, otherwise we write positive. In hydrides, calcium hydrides, lithium hydride, magnesium hydride, then there is a negative 1, otherwise hydrogen is a positive 1. So I am repeating again, gases, oxygen gas, nitrogen gas, they have a 0. Metal atom independently oxidation number is 0. In a compound, mostly oxygen is a negative 2, hydrogen is mostly positive 1. They are mostly same, but in other cases they may be changed accordingly I told you. So by using these, we will be able to calculate the oxidation number of the unknown element, which may be varied, which may be changed. Just like we have example, calculation of oxidation number. Oxidation number. Oxidation number. Apparent charge. Suppose the examiner asks you that calculate the oxidation number of manganese in potassium permanganate. I told you potassium is the alkali metal which has a positive 1 charge. Oxygen, I told you negative 2 charge. So manganese, this whole compound is going to be neutral, zero. It has zero oxidation state on the whole potassium permanganate compound. So this is a plus 1 and this is a minus 8, so I must put here plus 7. So this is the plus 1 alkali metal. Oxygen I told you negative 2, so manganese should be plus 7. And you done in the grade 9 the calculation I told you, this is a plus 1, then plus x, then plus minus 2 multiplied by 4 minus 8 is equal to 0. So this is the plus minus 8 and plus 1, this is the plus 7 and plus x is equal to 0. So this x will be equal to plus 7. That's the oxidation number of manganese is plus 7. Another example you have sodium thiosulfate. Sodium is a plus 1. So plus 1 multiplied by 2 plus 2. Sulfur is, we want to calculate oxidation number of sulfur. So sulfur we want to calculate it. There are 2, so I write 2x. Then oxygen is minus 2 multiplied by 3 minus 6 is equal to 0. So this is the minus 6 and this is plus 2. So it's a plus 4 plus 2x is equal to 0. So plus 4 is equal to 2x and x will be equal to 4 over 2 is equal to plus 2. So that's why on the sulfur there the plus 2 oxidation stage. So that's why you will be able to calculate oxidation numbers of the unknown these elements, just like sodium perchlorate. You want to calculate for the chlorine. Sodium is a plus 1, oxygen is negative 2. So this is a plus 1 plus x and minus 2 multiplied by 4 minus 8 is equal to 0. So this is the minus 8 and this is a plus 1. It should be a plus 7. Plus x is equal to 0. So x will be equal to plus 7. That's why on the chlorine there is oxidation number plus 7. So this method is used to calculate oxidation numbers. The questions are given in the exercise, you must solve them according to procedure given in your book. And you can calculate oxidation number of the ions, just like sulfate. Sulfate has a negative 2. It's a compound radical, molecular ion. It has total negative 2 oxidation number. So that's why oxygen is a negative 2. We can write like this one. Like this. Oxygen is negative 2. So I want to calculate sulfur X. Negative 2 multiplied by 4, negative 8, and is equal to negative 2 is a charge on whole sulfate. So if go there, then X will be equal to negative 2 and plus 8. So it will be a plus 6. So this sulfur is a plus 6 here. Like this. We have also dichromate. Dichromate, these are the orange colors, compound potassium dichromate, orange color. So dichromate has a negative 2 overall. We want to calculate for the chromium, oxygen is negative 2. So oxygen is negative 2, chromium 2x, because 2 are given here, minus negative 2 multiplied by 7, negative 14 is equal to minus 2. So this will be a 2x is equal to minus 2 and plus 14. So 2x will be equal to plus 12. So x will be equal to 12 divided by 2 is equal to plus 6. So on the chromium there is a plus 6 oxidation number. So dear students, these are the oxidation states of oxidation number. And now there is a very important thing, balancing of chemical equations. Balancing of chemical equations. So also there is one thing here, if the examiner asks you C6H12O6, calculate oxidation number of carbon. Calculate oxidation number of carbon. So this is 6x and plus hydrogen is a plus 1 multiplied by 12 plus 12, and oxygen is minus 2 multiplied by 6 minus 12. So that's why this will be 6x. So this will be minus into plus. This will be 0. This is going to be 0. So overall on the carbon there will be a 0. Overall carbon, this will be a 0, no charge on the carbon here in the glucose. So while balancing the chemical equation, you must know how we are going to calculate the oxidation and reductions and how we balance the chemical equations. So according to your revised syllabus or reduced syllabus, in the chapter number 2 electrochemistry, the article number 12.13 is a balancing of the chemical equations. How we balance the chemical equation? By using oxidation number method. By using chain oxidation number method. Chain oxidation number method. Balancing the chemical equations. Balancing chemical equations by using oxidation number method. Change oxidation number method. We will balance the chemical equation by change oxidation number method. So I am going to write the skeleton of the equation, then we have to balance it. So first write the skeleton of the equation from the question paper. Phosphorus plus nitric acid to give phosphoric acid, orthophosphoric acid plus nitrogen monoxide or nitric oxide. So we are going to balance it. After writing this equation, then write the skeleton of the equation from the question paper, then assign the oxidation numbers. So students, this is a free phosphorus. Free, I told you, 0. No charge on the free elements. Oxygen is a negative 2 and hydrogen I told you plus 1. So negative 2 multiplied by 3, negative 6 plus 1, so it should be positive 5. Oxygen is negative 2 and hydrogen is plus 1. Negative 2 multiplied by 4, negative 8 plus 1 multiplied by plus 3, this phosphorus should be plus 5. Oxygen is negative 2, but nitrogen must be positive 2 to make a 0. This is the oxidation numbers. We assign oxidation numbers or oxidation states. Then write again this chemical equation and you have to see where there is a change. Mark the change. Where the change, see very carefully, this is phosphorus. We go on here, phosphorus plus 5. So there the change. Make a bridge. This is a bridge. Make a bridge between phosphorus to phosphorus. Here. So this is a change 0 to plus 5. When I told you about the oxidation reduction processes, Oxidation is the loss of electron and reduction is a gain of electron. Oxidation is the loss of electron or increase in oxidation number. So in the phosphorus there is oxidation and there is a loss of 5 electrons. Difference of electrons are 5, 0 to plus 5. This is the difference of electrons. See the next element, hydrogen plus 1 and hydrogen plus 1, no change. Nitrogen is going to be changed. So this is the nitrogen, make a bridge. Go to the nitrogen. So nitrogen is, you are seeing positive 5 in nitric acid, and in the nitrogen monoxide or nitric oxide there is plus 2. Decrease in oxidation number is called reduction, gain of electrons. So this is the reduction, and this is the gain of, take a difference of these two, plus 5 changed into plus 2, so 3 electrons. So this is the gain of 3 electrons, this is the reduction. Then if you want to write these two in the half cell reaction, this is good, you can understand. See the half cell reactions, this is the redox reaction board. So after assigning, it is good to write oxidation means half cell reaction. Phosphorus 4, make a gap something, very visible. And this is a positive 5. Already I told you this is oxidation of the 5 electrons. Right here oxidation, loss of 5 electrons. And second equation, nitric acid. This is the nitric acid, positive 5 nitrogen, changes into nitric oxide, nitrogen monoxide, oxygen negative 2 and nitrogen is positive 2. And then the reduction of 3 electron. This is the reduction process. So while splitting this equation in the two half cell reactions, now there is one very important thing. When you are going to add two half reactions, these electrons must be equal, same. Oxidation electrons, reduction electron must be same. So students, how I get the same? When I multiply this equation by 3, then it will be a 15. When I multiply this equation by 5, this will be 15. Same electrons on both sides, then it will be cancelled. Then I can add these two half cell reactions to make the overall. This is important. Must you have to equalize them. So students, multiply this equation by 3. So I am writing again 3 phosphorus. Now no need for oxidation number, don't put oxidation number. 3 phosphorus changes into 3 phosphoric acid, orthophosphoric acid. No need to give oxidation number. 15 electrons are going to be oxidized. Multiply by 5 this, 5 nitric acid, 15 electrons are reduced to give a 5 nitric oxides. Now students, you can easily add them because 15 electron oxidation and 15 electron reduction are going to be cancelled out. Now write whole equation. 3 phosphorus plus 5 nitric acid give 3 phosphoric acid plus 5 nitric oxide. So when we sum, you will get, then after this step, then you have to balance the rest of equation yourself by hit and try method. You have to balance rest of the equation yourself. Suppose you are seeing there is oxygen, 3 oxygens are here and 3 5 are 15. 15 oxygen atoms. 3 4s are 12. And 5 is here. So this becomes 17 now. And hydrogen 3 multiplied by 3, 9. And phosphorus is 3. And nitrogens are 5. So how we are going to balance the rest of equation? Is there any water or not? Yes, there is. Phosphorus. There is also water. We forgot here. We forgot here to write the water because it's not going to participate. In the main equation, there is also water. So now you can balance. There are how many water is on the reaction side? See this one now. Total hydrogen atoms are 9 and here are 5. So students, you have to put 4. So plus 5 nitric acid plus 4 water molecules. So when I put the 4 water molecules here, then 2 4s are 8 and 3 4s are 15. 15 and 4, there are 19. Oxygen are 9. Hydrogen are 9 here, 5. So 5 hydrogen, 2 multiplied by 2, 4 and 5, 9, and oxygen 3, 5 are 15, plus 2, 17, 3 and 3 hydrogen, and 4 oxygen, 4 and 5, 9, 5 nitrogen, there are 5 nitrogen, 3 phosphorus, your equation is balanced. Your equation is balanced now. Now I am going to repeat this procedure. Write the full equation. There is the water also. Phosphorus, nitric acid, water, phosphoric acid, nitrogen monoxide. Assign 0, positive 1, oxidation, loss of electron. Positive 5, positive 2, reduction, gain of 3 electrons. Make half set, 0, positive 5, oxidation 5 electrons. Positive 5, positive 2, reductions 3 electrons. Then I told you that you have to balance these electrons. 5, this equation is multiplied by 3, so 15 electrons. Then 3 multiplied by 5, 15 electrons. Then add, also water you have to put, because it is present in the chemical equation, so I must put here. So then this is 3 phosphorus, I put 3 phosphorus, 5 nitric acid I put here, then I put water here, electron cancelled, 3 molecules of phosphoric acid I write, and 5 molecules of nitric oxide also. Now then I have to balance the hydrogen and oxygen both. So there are 5 hydrogens, 3 multiplied by 3 hydrogens are here 9, and also there are 4 here, 5 here, then water is also here. To make 9 I multiply by 2, this 2 multiplied by 2, 4 and 5, 9, hydrogen is balanced. Oxygen 3, 5 are 15, 15 to 17, 3 4 are 12 plus 5, 17, 3 phosphorus, and there are 5 nitrogen atoms, and there are 5 nitrogen atoms. If you look your book, this is salt, and you will get the same answer. You will get the same answer. So there the self-check I'm going to solve here, and 1 or 2 maybe from the So students, there is one equation I want to solve. So I am going to write the chemical equation from self-check. Nitric acid plus hydrogen sulfide, nitric oxide plus sulfur plus water. This is a self-check 12.3. Now assign oxidation numbers. Say nitric acid -2 plus 5 plus 1, hydrogen plus 1 multiplied by 2 plus 2, sulfur is -2, oxygen is -2, nitrogen plus 2, element form 0, -2 and plus 1. These are the oxidation numbers. After assigning oxidation numbers, there is a change in oxidation number. You can see here. Plus 5 to plus 2, this is a reduction. This is a reduction, and this reduction is for 3 electrons reduction, and there is also oxidation here in sulfur. -2 changes into 0, oxidation number is going to be increased. So this is the oxidation. Go backward counting, -1, then 0. So this is the oxidation of the 2 electrons. 2 electrons are going to be oxidized. Hydrogen same and oxygen is also same. So write half cell reactions for oxidation reduction. Hydrogen sulfide plus 1 changes into 0. So this sulfur is -2 and this sulfur is 0. There is oxidation of 2 electrons. Oxidation of 2 electrons. Write nitric acid plus 5. This changes into nitric oxide, -2 and plus 2. and this is the reduction of 3 electrons. Students, see, here are 2 electrons and here are 3. So equalize them. I multiply by 3 this. 3H2S. Don't write the oxidation numbers. And this will be a 3 sulfur and plus 3 2 are 6. So 6 electrons. Multiply by 2 is 2 nitric acid, 6 electrons, and there are 2 nitric oxide here. Electrons are cancelled. Now write whole equation. You have the 2 nitric acid plus 3 H2S, 3 H2S, and then to give 2 nitric oxide plus 3 sulfur, and there is also water in the overall equation. Now balance by yourself by Heckert method. There are 2 hydrogens, 2 3 are 6, 6 and 2 8. So there multiply by 4. Oxygen multiply by 3, 6 and 4 are here and 2 are here. So 6. Nitrogen there are 2 and nitrogen there are 2. Sulfur there are 3. Sulfur is balanced. This equation is balanced now. Assign oxidation numbers. See the change. Mention oxidation reduction with electrons, oxidation numbers. Balance the electrons, oxidation reduction. Sum the 2 half cell and balance the rest of equation yourself by hit and trial method. So students, I continue this with technical these equation to balance. In exercises there are many equation to balance and there are some very complicated and technical. Inshallah, I will continue this balancing equation in the next lecture. Thank you very much.